Okay. So in the last class, we discussed about the one method of solving first order first degree equation, that is separation of variable, and we start with the Bernoulli's equation. So what is the Bernoulli's equation? Bernoulli's equation. So yeah, equation is of the form, the general form of first order equation, that is dy by dx plus some p. This p may be function of x or constant times y equal to q times y power n. Okay, this is q times y power n, where this p or q are constants or functions of x alone or functions of y alone, or functions of x alone. Or y alone. Okay. Now this n is any constant, but n is non-zero and then not equal to. So this equation is called Bernoulli's equation. Now what is the solution? How to find the solution of this one? So first you got to divide this equation by y power n. So therefore this equation reduces to y power minus n dy by dx plus p into y power 1 minus n equal to q. Okay. Now we call this y power 1 minus n is some v. So let our put v equal to y power 1 minus n. Now this equation is in terms of y and dx. Now we have to convert into in terms of v and dx. Therefore we have to differentiate this equation both sides by with respect to x. Therefore dv by dx equal to, if we differentiate this, we have a power 1 minus n into y power. You can add one power, therefore we get, sorry, we got to subtract 1, therefore we get minus n. And if we differentiate y, you get dy by dx. Now replace, therefore maybe we call this equation number 1. Therefore 1 becomes, this factor is nothing but 1 by 1 minus n times dv by dx plus p times v equal to q. Now multiply this 1 minus n, we have a equation dv by dx plus 1 minus n times p times v equal to 1 minus n times q. So now this is a first order differential equation. Now you got to find the, once you write in the form, then first you got to find the integrating factor. So what is the integrating factor? It's nothing but e power integral this term. So that is 1 minus n times p into dx. So once you find the integrating factor, the solution is, so here the dependent variable is v. Therefore v into integrating factor equal to integrating factor into this right hand side function, that is 1 minus n into q into dx plus c. So now we know that v is nothing but y power minus n, then we have to substitute here. Therefore finally we have to replace v equal to y power minus n into integrating factor equal to integrating factor times this. This is our required solution for Bernoulli's equation. Okay. Now we solve some problem to find the solution of Bernoulli's equation. So exercise, solve dy by dx plus x into sine 2y equal to x cube cos cube y. Okay. So we have to divide x cube both sides. This is a Bernoulli's equation, right? So either it's a x function of x alone or function of y alone. Now what you get? So if you divide both side by this cos of uh, cos square. I think no, cos square is actually not cos cube, it's actually cos square. So divide cos square y both side. Therefore, 1 by cos square is nothing but secant square y into dy by dx plus x into no, I think here I did some mistake in the problem. Okay, anyway, so what is actually we know that sine 2y is sine 2a formula is 2 sine a cos a, right? Sine 2a formula is this one. Now, if you divide by cos square y, can divide by cos square y, we can cancel one cos y. Therefore, sin y by cos y is nothing but tan y. Therefore, this term we get 2 times tan y times x equal to x cube. Okay, got it? We got to expand the sin 2y is nothing but 2 sin y cos y. We can cancel one cos y. Therefore, sin by cos is tan. Now, again, so directly you can simplify this. So call this tan y is v. So let v equal to tan y. Now, what is dv by dx? What is the derivative of tan? Is secant square y. And what is the derivative of y? dy by dx. Right, you have to apply the chain rule. First, you have to apply take the derivative of tan and then take the derivative of y with respect to x. You get this one. Now, secant square y dy by dx nothing but dv by dx. Therefore, this equation reduces to dv by dx plus 2vx equal to x cube. Now, what is our p is 2 times x. What is our q is x cube, right? Now, what is the integrating factor? So, this is an equation in v and x. Therefore, the integrating factor is e power integral p dx. So, that is the integration of 2x is x square by 2. 2 cancel, we have e power x square. So, that is the integrating factor. Therefore, the solution is v into integrating factor is e power x square equal to integration, the integrating factor times q. What is q? X cube into dx plus c. Okay. Now, we call this x square is some t, change of variable. You take x, t is x square. Now, what is dt? 2x dx. Therefore, this equation reduces to v into e power t equal to integration e power t into, and this is nothing but x square x cube dx. X cube can be written as x square into x, okay, into dx. Suppose if you take dx. So this x dx can be written as dt by 2. So therefore, x dx can be written as dt by 2, and then x square we can write t. Therefore, we can write t into dt by 2 plus c. Now you can take 1 by 2 outside. Therefore, integration you got to write integral u dv format. Therefore, into d into d of t into d of e power t. Because if you differentiate e power t, you get e power t dt. You get same thing. So we can rewrite this. You have to apply integral u dv formula. So therefore, apply what is the definition of the uv formula is uv minus integral v du. What is the derivative of t is dt plus c. Now, what is the derivative integration of e power t is e power t. So therefore, we get 1 by 2 times t e power t minus e power t plus c. You can take e power t outside. So therefore, we get v into e power t is this. Therefore, if you multiply both sides by e power minus t, we get 1 by t times t minus 1 plus c into e power minus t. Okay, because if you take e power t outside, it cancel and we get the. Now this is a solution. Now replace t by x square and then v by what we take tan y, because we take v equal to tan y. So finally we replace everything. So therefore the solution is tan y equal to 1 by 2 times x square minus 1 plus c times e power minus x square. So this is a solution. Okay. Here we have a there is no function of y here anyway, so we can directly apply change of value. You can call p equal to this. This is not exactly is of the form Bernoulli's equation, but we have to. So another type of Bernoulli's equation. So okay. Anyway, you should know the method to solve the Bernoulli's equation. We give this. You have to call y v equal to y power 1 minus n and then get in the general form. So therefore, so far we discussed the solution of the first order first degree equation. So what is that? So quickly we recall. Either the coefficients are either variable or constant. If you take any first order differential equation like this, dy by dx some p times y equal to q. So this is a general form of first order differential equation, where this p, q are functions of x alone or both are constant or any possible. In any case, the solution is y into integrating factor equal to integrating factor times q into dx plus c, where the integrating factor is nothing but e power integral p dx. Okay, either p is functions of x or p is constant, we can easily find the integration p dx and then take substitute. So just to substitute integrating factor and then you have to integrate the right hand side, you will get the solution. So this is very important formula. So only differential equations of form this. Okay, and suppose we have some other thing is there, we will discuss that exact equation. So when we say a first order differential equation is said to be exact. Okay. Now we discuss that one. That is very important thing. Okay. Exact differential equation. So there are some forms there. The first form, suppose there are two functions of x and y. Suppose if m and n, capital N and capital N are functions of x and y. Functions of two variable x and y, then the equation m into dx plus n into dy equal to 0. So this is some differential equation. So this equation is called an exact equation. Is called an exact differential equation. If you differentiate this m partially with respect to y, that is dou m by dou y, it should be equal to, if you partially differentiate to n with respect to x, If both are equal, then the differential equation is said to be exact differential equation. Okay, that is if and only if, because m is a function of x and y, n also function of x and y. If you differentiate partially with respect to y or m, and it should be equal to dou n by dou x. Okay, dou n means it's a partial derivative. Okay, now once the equation is exact, how to find the solution? So first you have to check the equation is exact or not. So that is, you have to check this condition. Suppose what is the working rule to find the solution of this equation? So first thing is, you have to check or verify the equation is exact or not. So the first you have to check, verify this m into dx plus n into dy equal to 0 is exact. So that is what we have to check. We have to check dou m by dou y will be equal to dou n by dou x. If this is satisfied, then go to the next step. So what is the next step? If it is exact, then integrate m with respect to x and treat y as a constant. Okay. So if exact, then integrate the function m with respect to x, and take y as a constant, or treat y as a constant and then integrate with respect to x. That is the first thing, constant. Now the next step is, now integrate n. Okay, consider the terms of n, consider the terms in n which contains x. Okay, you have to omit that term. Okay, anyway, so consider the terms in n which are free from x, and integrate with respect to y. Integrate this with respect to y. Okay, suppose if n contains some x term, you have to omit all the x term in n, and then the remaining things we have to integrate with respect to y. Okay, so now you get one equation from the second step. Okay, so integral m dx you will get. Okay, here you have to fix y as a constant. Okay, in the case. Now in the second case, the third case, you have to integrate n with respect to y, but here x not in x, not x. We have to omit all the x term in n and then integrate with respect to y. Now you'll get two equations, this and this. Sum these two and then equal to some constant, that is a solution. Now the final step is sum these two. The sum of these two equations equal to constant. The sum of these two equations equated to a constant, is the required solution. So that is, solution is integral m dx, but you treat y as a constant here, and plus integral n dy, no x term in n, and then integrate, and you take some c, that is a solution. Okay, now we discuss some example. First, you have to identify what is m, what is n, and then check is it exact or not. If it is not exact, then we have to convert the equation become to be exact. We will discuss that later. So now solve this problem. So find the solution of the differential equation x square minus 4xy minus 2y square into dx plus y square minus 4xy minus 2x square into dy equal to 0. Okay. Now the coefficient of dx is m. Okay. So therefore, what is m? Let m m is nothing but m of x comma y, because it's a function of x comma y. So m of x comma y is nothing but x square minus 4xy minus 2y square. And what is n of x comma y? Is y square minus 4xy minus 2x square. The coefficient of dy is m. Now first you have to check the equation is exact or not. So first you have to differentiate m partially with respect to x, with respect to y. Dou m by dou y. So that is, you have to treat x as a constant. So therefore derivative of x square is 0, and if you differentiate this, since 4x is a constant, therefore we get minus. If we differentiate y, we get 1, therefore minus 4x. And here we get minus 4 times y. This is dou m by dou y. Now what is dou n by dou x? Then here we have to treat y as a constant. Therefore we get minus 4 y, because if we differentiate minus 4x with respect to x, we get minus 4y. And if we differentiate this, we get minus 4x. Now both are equal. Okay, so dou m by dou y equal to dou n by dou x. Therefore, it is exact. It is an exact equation. So if it is exact, then go to the next step. We have to integrate m with respect to x. We have to treat y as a constant. So it's nothing but integral. What is m? M is nothing but this x square minus 4y xy minus 2x square. So m is x square minus 4xy minus 2y square into dx, but you are treat y as a constant. Now what is the integration? Integration of term by term integration. Integration of x square is x cube by 3. But here we treat y as a constant. You can take outside from the integration and then integrate 4x. We get x square by 2 to cancel. We get a minus 2x square y. Okay. Now integration of y square, since 2y square is a constant, we can take outside. Integration of dx is x. Okay. So this is the integration of m with respect to x, and treat y as a constant. Now next one is integration of n with respect to y, but we have to remove all x term, that is not x, not in x. That means what? We have to omit, or we have to remove all the x term in n. So therefore, since x term contains here and here, we have to omit all the term which contains x. Therefore, we have only y square. Therefore, just y square into dy. Now, what is the integration? Y cube by 3. Now, sum these two and then equal to constant, that is a solution. Therefore, solution is x cube by 3 minus 2x square y minus 2y square x plus the another term is y cube by 3 equal to some constant c. So this is a solution. Okay. Any doubt in this? So if the equation is exact, then we know how to find the solution. Now suppose the given equation need not be exact. Sometimes it's not exact. So therefore we got to multiply some function both the side of this given equation m dx plus n dy, some mu function, some mu. Such a mu is called the integrating factor. Okay. If you multiply some function to this equation both side, then the equation becomes exact equation. So you have to multiply mu both side mu into 0 is 0 anyway. So the equation becomes exact, and then we will get a solution. Okay, so such a function mu is called the integrating factor. So how to find the integrating factor for not exact equation? Okay. Okay. Now another way of solving this uh, equation, grouping method. We have to group all the x term one group, all the y terms are another group. We will get can directly integrate and then solve. So another one is grouping method. So that is we have to group x term alone, y term alone, and then you have to get. Okay. Now exercise for this method, solve y plus sin y into dx plus x plus x into cos y into dy equal to 0. Now we can multiply dx inside, we get y into dx, I take this term, and then x into dy, another term. So here and then sin y into dx plus x cos y dy equal to 0. Now the first two term we can write d of xy, because this is of the form, because if fix x and then differentiate y, if fix y and then differentiate x, we get y dx plus x dy. Therefore this is nothing but d of xy. Plus again we can write this into d of something, so it's nothing but x of what, sin y, because this will look like u dv formula. Okay, u dv, sorry, that is a derivative of uv. So you have to fix x and then differentiate sine, we get cos y, that is nothing but this one, and then differentiate y, we get dy. Now fix sine y, if you differentiate x, we get dx, this term. Now we form the group, and this is equal to 0. Now directly integrate both sides. If you integrate, the derivative symbol cancel, we get, if you integrate, we get xy plus x sin y equal to constant. So this is a required solution. So this is a grouping method. Okay. Okay. Now suppose that the first order differential equation like m dx plus n dy equal to 0 is not exact, then we have to multiply some function. Such a function is called integrating factor. So definition, suppose if m dx, so whenever I am using m means what, is a function of x and y. Again n also function of x and y. Okay. So n dy equal to 0 is not exact. Suppose is not exact, then any function mu, then any function mu such that if you multiply mu both sides to this equation, that is mu of m dx plus n dy equal to mu into 0, that is 0. This equation is exact. Okay. So that is, if you take any function satisfy this, this equation becomes exact. Become exact. Such a function mu is called integrating factor. Is called an integrating factor. Any function mu satisfy becomes this equation becomes exact. Such a function mu is called the integrating factor. Okay. So therefore, if the equation is not exact, we have infinitely many integrating factor. So note, the differential equation possesses an infinite number of integrating factor, not unique integrating factor. It has infinitely. So mark as note, the differential equation m dx plus n dy equal to 0 possesses an infinite number of integrating factor. Infinite number of integrating factor if. Okay. Now the next thing is rules for finding integrating factor. So what are the rules to finding the integrating factor? So the next one is rules for finding integrating factor, finding if. So provided, so we find the integrating factor only when the equation is not exact. Okay, not exact means what? Dou m by dou y not equal to dou n by dou x. Okay. Now, what is the first rule? Rule 1. So what the rule 1 says, suppose the given equation is homogeneous. So if the given equation m dx plus n dy, that is n dx means what? M of x comma y. Okay, so keep in mind. So m of x comma y into dx plus n of x comma y dy equal to 0. So if the given equation is homogeneous, homogeneous means what? This both the function m and n is homogeneous. Already I mentioned that what is homogeneous. If you replace x by lambda x and then y by lambda y, this should be equal to lambda power some n into m of x comma y. Okay, and similarly n also homogeneous. N of lambda x comma lambda y should be lambda power n times, both have same index n, so n of x comma. So that is homogeneous. If both m and n are homogeneous in the given equation, homogeneous, and suppose m into x, you have to multiply x to the function m, and n into y, you have to multiply y to the m. Suppose this is non-zero, then the integrating factor is then 1 by mx plus ny. Mx plus ny is an integrating factor. Is an integrating factor. So once you find the integrating factor, you have to multiply this 1 by mx plus ny to the given equation. The given equation becomes a exact equation, and then you know the rule to find the solution of exact equation. Okay, this is the first rule. Now another rule is to find the integrating factor. Rule 2. Suppose the given equation is of the form, so if the equation m dx plus n dy equal to 0 is of the form some function of xy, okay, into y dx, plus here also function of xy. So function of xy means what? Either xy square, xy cube, xy. So xy term is always should be in multiple. Okay, into y into dx, and here f2 of some function of xy into x into dy equal to 0. Suppose the given equation is of the form like this, then the integrating factor is then 1 by mx minus ny. 1 by m into x minus n into y is an integrating factor. Okay, so provided the given equation is of the form function of xy into y dx and plus function of xy into x dy equal to 0. So you can directly take 1 by mx plus ny is an indirect factor. You have to multiply this function. This is our mu. Okay, so you have to multiply mu to this equation. Then the equation becomes exact, and you can find the solution. Now next one is rule 3. Third rule. Another rule to find the integrity factor. Suppose if you find the number factor 1 by n, because already you know what is n, what is m, everything, into dou m by dou y minus dou n by dou x. Because we know that these two are not equal. Because if it is equal, then it is exact. Okay, no need to find the integrating factor. If it is not equal, then the subtraction non-zero number. Okay. Suppose if you find this factor, this function, so suppose this is a function of x alone, is a function of x alone, say some f of x. We simplify these, you will get some function of x alone, say f of x, then the integrating factor is then e power integral f of x dx is an integrating factor. Okay. Now the final rule is, suppose this is not a function of x, then you have to check the another one. Rule 4. Suppose 1 by m, if 1 by m times dou n by dou x minus dou m by dou y. You find this. Suppose this is a function of y alone. Is a function of y alone. Y alone. Say some g of y. Say g of y. Then the integrating factor is then e power integral g of y dy is an integrating factor. Okay. So these are all rules to find the integrating factor of a not exact equation. Okay. So depending upon the problem, you have to choose which rule. So depending upon the problem, you can choose the rule. Okay. Maybe I will ask one question. So problem: find the integrating factor of find the integrating factor if of the equation x square plus y square plus x into dx plus xy dy equal to 0. So first you have to check this is the exact equation or not. Anyway, they are asking integrating factor, therefore definitely it's not exact. So what is m here? M is x square plus y square plus x. Okay. Just 1 minute. Okay. So now m is x square plus y square plus x, and n is xy. So if you find dou m by dou y, not x, okay, keep in mind dou y. To differentiate y, you get 2y, because only the y term is the y square term, all are 0. So if you differentiate n with respect to x partially, you will get just y. Therefore 2y is not equal to y. Therefore dou m by dou y not equal to dou n by dou x. Therefore it is not exact. So you have to find the integrating factor. It's not exact. Now, which rule we have to use? So anyway, this is not homogeneous. Okay. because if you take replace x by lambda x, you'll get lambda square x square here lambda square y square here, but here we get just lambda x. So, but anyway, here we get lambda square xy. But anyway, this is not a homogeneous equation. Okay, so therefore you are not allowed to use the first rule, because the first rule says if both m and n are homogeneous, then we can directly write 1 by mx plus ny is the integrating factor. Now look at the second rule. Suppose the given equation is of the form some function of xy into y dx. Okay, it's not is of the form. Okay, because it's not a function of this one. Okay, now look at the third rule. So anyway, we got to apply either third rule or fourth rule. So we got to divide 1 by n times this subtraction. So already we know that this is 2y by this one. So what is 1 by n times dou m by dou y minus dou n by dou x. N is nothing but xy. Therefore 1 by xy times this is 2y minus y. Therefore this is y cancel. We get 1 by x. This is f of x. Therefore we get a function of x alone. Therefore 1 by x is f of x. Therefore the integrating factor is e power integral f of x dx. Therefore it's nothing but e power integral 1 by x dx. So 1 by x is nothing but log x. Therefore e power log x nothing but just dx. Therefore integrating factor is nothing but x. Okay. This is a method to find the integrating factor. So once you find the integrating factor, now x is the integrating factor. Now you have to multiply this x to the given equation. You will get the equation becomes exact equation, and then you get solution. Okay. So the solution will not change because you are multiplying the some number both the side. Therefore it will not change anything. Okay. The solution does not change. So if you multiply x both side to this equation, we get x cube plus xy square plus x square. That is our m. And what is n? X square y. That is our n. Now find dou m by dou y. Okay, you get a 2xy. If you find dou n by dou x, you get 2xy. Now we get both are equal. Now, how to find the solution? Now integrate m with respect to x, treat y as a constant, and therefore integral m dx is nothing but x power 4 by 4. We have to treat y as a constant, therefore x square by 2, therefore x square y square by 2 plus x cube by 3. Now integrate, we have to integrate n with respect to y, but we have to omit all the x term. But look at the n. Okay, so n contains x term, therefore we get 0. Therefore should be 0 because n becomes 0 because only term and that term also contains x. Therefore just add these two, therefore 0, therefore we can directly write this is equal to c. So this is our required solution for this. Okay. So now we completely finished the first order, first degree differential equation solutions. Okay. So for any doubt, you can ask now. So in the next class, we find the linear second order differential equation. Okay. And then how to find the solution. And there are two cases, homogeneous, non-homogeneous. But in the first order, we write the general formula y into integrating factor equal to integral integrating factor into q of x dx plus c. Okay. If it is homogeneous, that means what q is 0. So we can easily find the solution. So you try to solve some problems in the first order differential equation, and then we will discuss in the next class second order differential equation. Okay. Now we stop the class. Thank you.